Thank you very much. Hello, everybody. It's so exciting to be here. My name is Julio. I'm joined by Randall. We are from the developer relations or technical evangelism team. And this means we have the best job in the world. That's to be here with you guys, talking directly, developer to developer, no sales, no marketing, just code and infrastructure and whatever you guys want to hear from us. And as our job is communicating back and forth with you, it's important that we have a common language. And unfortunately, I'm from Brazil, so that's not Korean, unfortunately. So let's try JavaScript. Who here is a JavaScript developer? Written any kind of JavaScript code? All right, all right, all right. And that's not easy. That's not hard to understand, right? JavaScript is on every platform. Every user has at least a couple JavaScript interpreter on their machines. So, but it was developed initially in 10 days, so it has its quirks. But like it or not, it's there, and we all pretty much have to learn it. And we have a lot of that on AWS. So I'm here today to show you how much you can accomplish with JavaScript on AWS and how to do it. So let's just go on. So if you look at the tools page on the AWS website, that's awsamazon.com/tools, you see that we have a lot of tools for developers, but it's important to understand how they communicate. So the console, the command line tools, the IDE toolkits, they are all built using the software development kits, the SDKs for several languages, and those access the same HTTP services everywhere else. So it's everything in the end, it's making HTTP calls to those web services that you can even call them directly, but it's much easier if you go through the SDKs. And today we're going to talk about two SDKs in particular, the browser SDKs and the Node.js SDKs, and because those are the two environments that support JavaScript. So let's start with Nodejs Backends. So for those of you, Node.js is an interpreter for JavaScript that can run on any environment. It can run on any machine, on your machine, on the cloud, like everywhere. It's installed with the same NPM and regular tools that you would use for JavaScript applications. And here's one example of how to use that. So suppose you want to make an album application, a picture application, such as Instagram or any Instagram-like apps we see nowadays. This would be the kind of code that you would see. It's just a matter of instantiating the AWS configuration and the S3 client object and calling operations on them. A small tip, never add security credentials directly to your code. The SDK will fetch them from environment variables or the EC2 metadata if it's running on EC2. So really avoid getting those hard-coded so your credentials don't end up in GitHub, as we've seen happening sometimes. And once you have that S3 object, you can call the same operations that you would on the console, such as upload a part, or list objects or put objects. Everything that you see on the console or that you use on the command line is available on the SDK as well. And here's how you would use such a thing. So that object that we instantiated, S3, is a client to the S3 web service that you can call the upload method to send a photo, for example. And the important thing is you understand those methods. For example, they can be very similar, such as put object and upload are a bit different. You can use put object to send an object a single time, or upload using intelligent concurrent handling of streams. So if you have a large file and big bandwidth, it will send more connections at once in the upload. So take a look at those methods, they really pay off. And once it's time to deploy that, you can do as you would in a regular traditional infrastructure and create everything yourself. But I would recommend that you use Elastic Beanstalk. Elastic Beanstalk is our service for deploying and managing whole sorts of applications. You could use Docker, Java, several environments, and that includes Node.js. The difference is that with Beanstalk, you just upload the zip with your code, and you have a complete DevOps environment so that you can configure auto-scaling and integrate with databases and change URLs to make blue-green deployments and things like this without any effort, without writing any scripts that you would need if you were deploying yourself. But there is a next step that's going the serverless way. So this is a trend that you're seeing growing more and more about not managing servers at all. So don't build your servers, you don't even need to configure them using Beanstalk. Just send your code to AWS Lambda and it will run it for you. Randall, after me, is going to talk more about Lambda and make a deeper dive than I will, but there's a lot of that today. And when Martin Fowler speaks about it and there's a conference about it, we can know that it's a thing. And here's how it looks like. So the SDK is already available for you, the AWS SDK library, so you don't need to add that to your package or anything. And you can use the same API, the same S3 API that you were using before. And you can see that all data that triggers your function is passed in as parameters. You have the event that triggered your function, such as an HTTP request, for example. You have the context in which your function is running. And you can see that we have support for a very recent version of JavaScript using fat arrow functions, const, and nearly all the ES6 features of JavaScript with Node 6.10 that's available in Lambda. And every Lambda function is invoked through triggers. And this can be a lot of things. This could be a call to a REST API, a device on AWS IoT, an Alexa queue. There's a lot of things that can trigger a Lambda function. Think of a Lambda functions as the Swiss knife of AWS. If you need to compute something, run something, you can run on AWS Lambda, and that can be triggered by many, many styles. So, for example, if you choose API Gateway, you can define your API, your HTTP methods and resources that you want, including parameters, and just bind that to Lambda function, saying that this method is going to trigger this Lambda function, and that can be just it. Or you can even define specific mappings from your request to your function and change how things are represented. This is pretty useful if you're doing legacy integration, where you need to integrate with lots of different resources behind the same API. And again, this is, you can think any kind of application, any REST API that you would use Express or any kind of RESTful framework to build this API. And one particular thing about API Gateway is that you have two ways to invoke the code. First, you have this invoke URL, and you can use fetch, the same old AJAX APIs that you use, jQuery AJAX, or even the curl, or any way you can fire an HTTP request to this URL, you get a response back. But this is not all clients need. Sometimes you need to retry if the connection isn't successful. You need to authenticate safely. You need to perform some operations on the client side, not just firing the request. And for that, API Gateway has this SDK generation. in which you generate an SDK in JavaScript, it generates automatically a client for this environment, for this API, and you can invoke it on your application. So just to show you what that looks like, for example, if we have a JavaScript app, here is a React application, and see that in this public folder, I have this API gateway generated files right here. So this API gateway client was generated automatically by AWS API gateway, and it will contain the methods for my application. For example, one of them is called featured items get, to get the featured items. And in my application, I can just instantiate this object with new client and call the methods that are defined on the API directly on JavaScript without even having to know how HTTP requests are sent. Okay. Another very useful feature of Lambda is triggering functions on a schedule. So many of you that are on developer, DevOps or system admins have to frequently perform tasks such as delete old versions that are no longer used, or delete old backups, or manage anything that must be done on a schedule. You can create a Lambda function for that and have it executed by any rate or cron expression without having to run your own cron jobs or your own Chronos cluster or anything like that. And this may be confusing at first, but the idea is that you can use all of those options. I think about it, I prefer using the most cost-effective managed services such as AWS Lambda. You can compose Lambda functions with another service called step functions and build very rich applications using that. But there are some cases with legacy libraries, perhaps, or applications that you need to have access to the underlying server and configure the underlying server properly. And that may be the case for Elastic Beanstalk. Or perhaps you already have your scripts, you already have your lifecycle management, you are doing things in multiple environments such as multiple clouds or cloud and on-premise, and you want to do the same thing, then you can customize the EC2, the auto-scaling, and run things on your own servers, and they all support the same JavaScript operations, the same JavaScript environments. For example, you can use some traditional JavaScript frameworks, such as Express, that are usually thought in a more traditional server-oriented deployment. But you can just create a bridge and invoke it from your REST API, call your Express application running on Lambda. And this is a pretty small code base. You can see in this example later. And this is for the server side of things. But it's also important that we talk about the client side of things. After all, JavaScript was born for the web client, for the web browser. And for the web browser, we have a different SDK because threads, I/O, and a lot of libraries behave differently on the client than on Node.js. And especially credentials, because on the server, you have control of how credentials are stored and managed. But on the client side, anything can happen, right? And you don't have access to the user browser that freely. So we need a more secure way to manage credentials than just shipping it with the code. And that's the job of Amazon Cognito. Amazon Cognito is a separate service that can be used with lots of applications, not necessarily JavaScript. It features basically authentication and data synchronization. So you can set up your application to have identities on Facebook, on Twitter, on Amazon, or even your own user base. Cognito also supports having your own registry of users. That's called your user pools. And once you have that, your credentials are managed securely by Cognito using JSON Web Tokens, encryption, and the best security AWS can offer. And also, as a bonus, you have data synchronization. This means if you're in one device and you mark an item as favorite on a web app, for example, and go to the mobile app and just pick your phone, it will be marked as favorite as well. So this kind of thing. And you can see that it's pretty much the same code that we had back there. We just have to add the identity pool ID and pass the credentials as Cognito identity credentials. Identity pools are resources that you create within Cognito, and it will automatically generate temporary credentials for your users with policies you define. So you can say that Cognito authenticated users can access S3 and Dynamo, but if they're not authenticated, they can use only S3, for example. This would be a policy, and the policies are going to be respected by the credentials that are generated for this client. And this is the web page for this. This is a separate SDK. You have the Amazon Cognito Identity SDK. Because if you don't want to use AWS for nothing else, you don't need the full AWS SDK with everything that S3, Dynamo, and all the client libraries, because from the client you probably only need authentication and perhaps invoking functions. So if you only want that, you can use only the Cognito identity, but if you want the full API, you can use both the Identity SDK and the AWS SDK. They integrate very well. When you use this SDK for Cognito, you can instantiate your objects using regular JavaScript files, or use modules as Webpack, or transpile with Babel if you're using Babel or React or something like this. And here is how you would code, for example, using Cognito. You provide your user pool ID, your client ID. These are resources created within Cognito. Your user pool, meaning your user database. Your client ID, meaning this application, because you can have several applications accessing the same user pool. And Cognito has a very peculiar API with this Cognito user attributes. This is how you say to Cognito what's the user email, what's the user phone number, and so on and so forth. And those are going to be stored by the Cognito database. All right. You don't have to, you have an API to access this data afterwards. But for example, the first use case that everybody needs is sign up. So when you call the method sign up on the user pool object, it will register the user with this username, this password, and this attribute list with email and phone number, and then wait for the user to confirm. Okay, so with this, this is just one use case. There are 24 more, including confirmation by SMS, email, and MFA. And it also extends to the Internet of Things. With the Node.js, you can run JavaScript on small devices such as Intel Edison, Raspberry Pi, or basically anything that have a Linux operating system probably can run Node.js and then can run the AWS SDK, right? And there is even a SDK for Arduinos and even less capable devices, but for JavaScript we need the OS, but that's pretty much standard these days. And for that there is a separate SDK, the AWS IoT SDK for JavaScript, supporting the publish and subscribe protocol Mqtt. And Mqtt, basically, you create, there are two APIs on the AWS IoT service, a device API and a Things Shadow API. The device API allows you to publish and subscribe to topics, and this is the idea, like a message bus. So there are message buses where you just specify your certificates and keys. So AWS IoT uses TLS mutual authentication, so the client recognizes the server recognizes the client through certificates that you generate on the service. And then you have these methods, the same events that you would have on regular Node.js apps. It's the same idea. When you have a message event, you can react any way you want, and you can publish messages to topics just by specifying their names and sending data, right? Pretty easy. Things Shadow is pretty much the same thing, but you have more events. So beyond the usual events such as connect, you have this status, data, and timeout events that report the state that device currently has. So this is good because if the device is not connected, for a while you may lose track of messages, and it can be difficult to track if it's on or off, if it's green or blue, what is this actual state of the object. And Things Shadow synchronizes the state of devices and the cloud automatically. So just as an example, this could be literally anything. I made a small demo here just to show you guys how this works. And so in my device, when it connects, I will connect to topics, and the idea is when I have a message, I'll show it to the user, and let me find it's just sending message to a topic and receiving message to a topic. And how that does anything, if you see this code, it doesn't do anything. It just listens for messages and sends messages back. It's not very relevant. The actual magic is going on in the cloud. So here in AWS IoT, I have a rule saying that every message that comes in this 8-ball topic is going to invoke a Lambda function. I could add any actions to this and store the message in a DynamoDB table, send it to a queue, store it in S3, but in this case, I just want to invoke this Lambda function. And this Lambda function just has an array of fortunes, of random strings that I pick at random. So the idea is that when I run this code, this is just that 8-ball toy. I don't know if this is. So if you think of a question, it will send a message to the cloud, and if it works, it's going to come with the answer to your question. This was made for an IoT device that I would need to press and make something more interesting, but the idea is the device of any kind. Right now it's my computer, but it could be a Raspberry Pi. Sending messages, the IoT triggers the Lambda function, and the message is displayed back. And this goes even further. Those functions are not necessarily on the cloud. There are some cases that you don't have time to wait, or maybe you don't have connectivity at the moment, but you need to invoke some computation right now. For example, if the temperature is too high, the building may be on fire, so you need to set fire an alarm or fire extinguishers or call the police or anything like this. So the devices can talk to a new service called Greengrass, and Greengrass can execute Lambda functions and manage device state locally on your network before shipping it to the cloud. And this would work even if you don't have stable internet connection. And going even a bit further on the network edge locations are these blue dots where you can have your functions or your state or your HTTP requests or your DNS queries answered more quickly as they are closer to end users. So in those edge locations, they are typically used just for HTTP cache, but recently they've been added with the capacity to run Lambda functions. So you can generate responses and perform computation directly on the edge location without going back to the origin, and that's a pretty powerful resource to make, especially for security, for routing, and a lot of use cases. Unfortunately, we don't have a lot of time now. If you'd like to learn more about coding and how to build JavaScript and all sorts of applications with AWS, I highly recommend you take a look at twitch.tv/AWS. That's where Randall and I and many others are live coding on stream, on the internet, live with you guys. So we are building things, looking at the chat, talking with you, moving to the direction you guys want to see, and building what you guys want to build, and helping you guys be successful with AWS. And we'd love you guys to jump in and talk to us anytime. And also, we are here throughout the conference and on Twitter anytime. Thank you very much.